Welcome and thank you for attending today's webinar, Collection System Flow Measurement, Increasing Safety and Minimizing Exposure. I'm John Trofatter, Director of Business Development of the Teledyne ISCO Water Platform. Before we start, we specifically want to recognize, acknowledge, and thank the unseen heroes of our society, the professional operators and maintenance workers of the water and wastewater industries. They are there every day ensuring basic and essential services are available 24/7. We appreciate that you're taking the time to attend this webinar and hope you find it time well spent. We do not intend to offer groundbreaking information relative to pathogens in general or COVID-19 in particular, but will offer some practical suggestions on ways to minimize exposure and simple ways to increase safety throughout your systems. We recognize the difficult aspects of current life and encourage all to practice the appropriately recommended precautions, whether at work or in our personal lives. We pray for all those that are suffering and have lost loved ones. As we endure these hardships, we will grow and become stronger together when we overcome the current ordeal. To quote Helen Keller, all the world is full of suffering. It is also full of overcoming. In this webinar, we're going to be covering a number of different topics, including normal safety practices, providing a couple of examples where there are changes in how things have occurred from the past to the current norm, non-contact options to measure flow, remote data analysis, and additional safety consideration, specifically intrinsically safe equipment. We also encourage you to consider the need for normal safety practices. This is our safety moment. So whether it's traffic control, guardrail, fall protection, PPE, ventilation equipment, or gas monitoring equipment, please continue to use the equipment as currently recommended throughout the industry. Additionally, here are some resources available to you for COVID-19. Water Environment Federation and AWWA both have wonderful details available from their websites, as well as AWWA sections and the Water Environment Federation member associations. We encourage you to reach out to those as well as tap into others as necessary. With that said, I'd like to introduce Rick Dey, the Teledyne ISCO Business Development Manager for Flow Meter Products.
Well, thank you, John. I'm going to go ahead and get started on this. So let's talk a little bit about what is happening in the collection systems. Well, as we all know, flow is still happening regardless of the coronavirus. So it's not going away. How do municipalities deal with this? And so I've talked to a fair number of these groups, asking them some questions on how are they dealing with this. Well, for the most part, it's business as usual. Their field crews are still going out. They're doing the jobs. So they're one of the essential groups that are typically out in the field. But what they're really trying to do is not come in contact or touch the water. So this is a big change. Nobody wants to touch the water, but especially now. Non-essential people are now working more from home. So even with the municipality, some of the engineering groups are working from home, as is with myself and some of the other folks on this webinar. Engineers still need the flow data. They still have to do their job. So that part is not going away. If anything, the accuracy of the flow data is required even more than ever. Non-contact is one of the areas where things have come a long ways in technology and is even more desired than ever before for obvious reasons. When you have a good non-contact system and don't have to have people in the hole or the manhole, it's nice to be able to use cellular communications to go ahead and collect that data. So a lot of cellular communications out there. So let's look at just a couple of examples of some cities that we work with that kind of how they've evolved and adapted to the latest changes in the world scenery. And you'll see this gentleman here is going in the manhole. He's all suited up. He has his protective equipment and he's ready to go. One thing that you probably have all heard about is UNMC, or the University of Nebraska Medical Center, and they're one of the leaders in treating the coronavirus as well as major other health disasters. They have a very large trunk line that feeds the wastewater plant, So it's especially important for them to get accurate data from that site. Up until just recently, the field crews were even forbidden to go in any manholes on this line. So it was really challenging to get good data. When I met with these folks, one of the things that they told me was this really all started from the Ebola virus. But Omaha, the way they deal with it, and especially in these lines, they use non-contact laser flow measurement techniques. It's both highly accurate and repeatable data, so they get what they need. Minimal maintenance, so they don't have to go into that hole and clean and calibrate. They also use a lot of remote communications, and that again has evolved a lot over the past several years, and it helps them do the job with their flow measurement with minimal staff and maintenance. So all of these have tied into some of what the city of Omaha is doing. Here's an example of what a non-contact sensor looks like when it's installed. They're very easy to install. There's really two bolts that hold the bracket on. You snap the sensor in there and away you go. Measure a level and you're measuring flow. One of the cities I've worked with in the Southwest, I had a good talk with them and wanted to get what are they doing, after, and so I got a good before and after response. One of the things that have changed, they wear those nice booties in the manholes. I'm sure a lot of you do that as well. They all are required to wear Tyrex suits for going into the manhole environment. Respirators N95 especially are required in that manhole. But one thing that has changed is face masks are now required for all personnel, even standing outside that manhole while they're making manhole entries. So that's a change in what they've done. One of the other things that has changed is they now require hydrogen peroxide to be used to clean any and all equipment that they use in that manhole. So whether you use wrenches, drills, gas detectors, you name it, anything that goes in there now is required to be cleaned using hydrogen peroxide. So let's take a step back, why we measure flow. This is a repeat for a lot of you, but I thought it'd be good to review anyway. Ionized studies, which are inflow and infiltration studies. What we're looking for is what happens when it rains versus the dry weather flow. So that's one of the main things. For those of you that may be international, in Europe, a lot of times they call them flow surveys. So enforcement requirements. Why do people require monitoring? Industrial pretreatment's a big one. They need to report to the municipality how much they're discharging. They may have to sample that water as well and be in line with their permit requirement. Billing or water custody transfer is another big one. So water custody transfer, I worked with some people out doing irrigation. So they're transferring water, they have to pay for that water. But more commonly, people refer to billing as cities that are discharging to other treatment works. And so you'll have a lot of cities out there, I'll just name a few, but Atlanta's, the Phoenixes, Milwaukee, Boston, Massachusetts, Denver, and the list goes on and on. And they have to report that flow data and get billed for it. Now, what are we going to use for equipment? It just really depends on your power is one of the big things. Do I have AC or DC power? Do I have solar power? You may use a portable meter on the right. You may want to use a permanent meter, the one that's on the left. So really depends on, again, power. What are your requirements? Do you want a data logger style where you're going to wake up, take a snapshot, and go back to sleep? Or do you want more of a permanent meter that's going to give you a live display and analog outputs? So you have to determine that as well. This is an example of a continuous wave Doppler area velocity flow meter. And the way these work, they wake up, they take a reading, they go back to sleep. It uses a continuous wave. So it's transmitting a signal out the nose to measure the velocity and does some sort of a level measurement. In this case, uses pressure, but there are different methods of doing that. Ultrasonic is another one. So you do a level measurement, velocity measurement to calculate the flow. Okay, so why would somebody use a non-contact sensor? The obvious reasons are safety. This picture is quite old, but I thought it was pretty good because you can see that this gentleman going down in there, although he's harnessed up quite well, really doesn't have all the protective equipment that you'll see now. One of the big reasons is obviously maintenance. I don't care what manufacturer you use. In this example, that AV sensor that's on the bottom is not going to read probably at all. So maintenance is a big one. Anybody that has seen something like this knows what's required to keep that up and running. So let's, another picture. This is a gentleman installing one. You'll notice he's also not really complying with the new rules of safety, but he's installing a sensor ring. On the left, you'll actually see what the sensor looks like. They're typically mounted in the bottom of the flow stream. And so for that reason, they may require more maintenance. Okay, so let's talk about some typical non-contact area velocity sensors. The one on the left is a laser subsurface velocity meter. The middle is radar surface velocity, and the one on the right is an ultrasonic surface velocity. So real briefly how these work, this is a non-contact radar surface velocity. It uses a ultrasonic to measure the water level, but it uses radar to measure the surface velocity. Here's another one on the left that you can see. It's a radar sensor installation, a slightly different one than I just showed you, but it mounts in the middle of the flow stream. Any surface velocity unit will require some surface turbulence in order to get a reflector, something to reflect back to the radar. In this case, it uses a very similar U-shaped channel mounting bracket to install the sensor like the one I showed you earlier. Here's one that's a non-contact ultrasonic sensor. And what this one does, it uses ultrasonic to measure the depth, and it will use the ultrasonic to also radar to measure the velocity of the water. All of these sensors are going to have some sort of deadband involved with it. So when the water comes and approaches the sensor, it will tend to lose the ultrasonic level signal. Here's a picture of one in a manhole. So you can install these outside the manhole pipe, or one actually up in the pipe. And so for this one here, you can see it's on a ring, but it is not in the flow. All right, so those are the most common surface velocity units, or radar. And now I'm going to talk about the non-contact laser subsurface velocity technique. And what this has a sensor that uses an ultrasonic like the other ones, measures the water distance to the water, or the water level. Once it knows where the water is, it will focus the laser below the surface of the water. So this is one unique difference between those techniques. The ultrasonic on this design is slightly different. It's mounted at an angle up into the sensor itself, and that's intended to prevent moisture from accumulating on the sensor face. The body has a built-in molded deflector plate, which will reflect that signal off of it and hit the water surface. The beauty of that is that it is a pretty much zero deadband design. So water will now go all the way up to, including submerging that laser sensor, before it will not read. And most of these have about anywhere from 0 to 10-foot range. Okay, so these are the non-contact area velocity techniques. And now I'm going to talk about some ways of using those without having to go in that manhole. I will start by saying, though, every one will require an initial confined space entry to mount some sort of a bracket. But in the case of this one, you'll see a yellow pole, and that's designed to go down into the manhole. It is a quick turn, and you can unsnap the sensor and just lift it right out. So it pulls out. It's easy to reinstall or remove the sensor. What's important these days with all these technologies would be the diagnostics information that you get from these sensors. So it's nice to say you can put one in and not have to do maintenance, but until you have diagnostic data, really don't know if you need to service the sensor or not. And if servicing is required, you can typically just remove it without entering that manhole. The other nice thing about these technologies would be that the sensor calibration is typically now stored in the sensor, so it's easy to reinstall without having to go back in for recalibration. So you can remove it, you can install it, and you can recalibrate without even actually having to do a whole lot. You can verify calibration's correct. Here's a picture of one that's in an industrial monitoring application. The thing to point out here is it's a nice round pipe, so it's easy. The hydraulics are good, so this is a good application. This is one on a wastewater discharge effluent line, and it's a little foamy, a little bit turbulent, not the ideal application. So these are things you want to look at from an application standpoint. When a sensor, in this case, the laser technique is used, it has a sensor that's mounted on the bottom, and it uses a continuous wave like one that you would see on a ring in a pipe. It also has a pressure sensor to measure the water depth over the sensor itself. So now you can calculate the depth of water in that manhole or the surcharge level. Here's what they look like when they go underwater. This is kind of a nasty one, but the reason I pointed this one out was because you'll see a nice log chain in there. So if you are using some non-contact technique, you may want to consider having a good stainless steel lanyard or a nice heavy log chain like this in case the worst case happens, which is shown here. So really the end game, what do we want? We want data. We need data for I&I or inflow and infiltration studies. Those typically require a large number of meters. Trending normally is more important than accuracy when you're doing a study like that. They need reliability and repeatability. So they don't want to go back in and have to replace sensors all the time and clean them. Accuracy is required now for typically hydraulic modeling. Again, I mentioned billing applications earlier, huge for those. Industrial monitoring, another one that's big because they're obviously paying money for that. The advanced diagnostics also helps us verify that the data that they're getting is good and for the most part accurate. Verifies the operation, again, quality of the data. So a lot of this is cutting edge stuff now and really helps you determine the data you're getting is good or it's not. And remote communications allow that to happen. So when I get into remote communications, let's talk a little bit about some of the antenna designs that are out there. And these are just a couple, but you'll see some pretty creative cellular phone antenna designs. The one on the left is what's referred to as a blade antenna, and it typically is stuck to the lid of a manhole. The one on the right is one that they had custom made where it's actually embedded into the manhole lid. This is a place in Colorado, so they have snow plows and wanted to make sure that the snow plow did not tear that antenna out. So we want to get them out of the manhole if we can. There's one on the left that's a newer style stub antenna. The one on the right is a whip style antenna. Believe it or not, you sometimes can get signal out of a manhole without having to core a hole in the manhole lid or run it out the side. This doesn't always work, but if you have good cell reception close to that manhole, you may be successful without having to put other holes in there. Here's one where it's in there's a hole in the manhole lid itself. So it's actually going down in there. There's a stainless steel shank and the antenna is bolted to that manhole lid. Here's one where they got a little bit creative with their blade antenna and they went ahead and they just used a two-part epoxy. They cleaned the lid real well and they went ahead and they glued that thing down on that, and that's worked well for them. Okay. Everybody now is going to more web-based data hosting or data capabilities, and we're in the same boat. So how does this work? You can have whatever meter you want. It has a built-in cellular modem. The units take their readings, and then at a programmed interval, it will go ahead and it will transmit that data via the internet, and it can go to a cloud-based or even a customer-hosted server. Once it's in there, people internally in the organization can view the data on a client server, but you can also VPN or look at web-based data off-site. So a lot of good ways with communications these days. So let's talk a little bit about intrinsic safe and where things are going with that. What is NFPA? What is Zone 0, Class 1, Division 1? And we looked at some of the customer needs and what people are, or where the market is going, where the industry is going. Well, industrial safe environments, the standard applies to really collection systems, combined sewers, storm sewers, pump stations, water treatment plants or wastewater treatment plants, sludge handling facilities, chemical handling facilities, treatment facilities, pretty much any place where you have a very nasty environment. So the hazardous rating for a sewer manhole is typically rated Class 1, Division 1, and more consultants coming out of college especially are specifying Class 1, Division 1, And why not? If the capability is there, you're just adding another layer of safety. In Europe, they use what's called ATEX Category 1G or Zone 0 for international. And there's also different ratings, IECEX rating for other parts in the world. So in conclusion, flow measurement is going to continue despite the world situation. Entering a manhole is more of an issue, as we all know, than ever before. Nobody wants to go in. Nobody wanted to go in before this, and they certainly don't want to go in now if they can all avoid it. Dangerous hydraulics was the main reason. In the old days, nobody wanted to get into a channel that was running 3 feet per second at 3 feet deep. So dangerous hydraulics were primarily the concern, but now we're seeing more of an issue with what's in that water. Stuff has always been in the water, but now we're just more aware of what dangers are out there. Non-contact area velocity technologies give you a much more flexible, enhanced measurement ability. You can do now accurate, safe, and remote collection of data, and that's where the future is going. And when you have safe, you have good equipment, you have now the ability to use intrinsic safe equipment, so you further increase the safety of your personnel in that manhole. And with that, I'll turn that over to questions.
Okay, I got a couple questions here. One is, can we use solar power, DC power for the non-contact device? And the answer is yes, of course you can. There's different types of solar panels and different wattage ratings. So you really want to look at where you're at in the world, and of course contact us if you have any questions. We'd be happy to help you answer those. What you're gonna, or recommend what you would use for a solar panel. So different types of deep cycle batteries, solar panel, but yeah, you can certainly do that. So that's a good way to do it. Second question, non-contact. Is non-contact affected by depth? We have had standard area velocity meters in the past, and it seemed like when the water depth got higher, then it would have a more difficult time giving us accurate data. So traditionally, a non-contact is going to look either the surface or below the surface in the case of some of the other techniques. And really what we want to do is see below the surface where the peak velocity is, but that peak velocity is going to follow the surface regardless of level. So the nice thing about the non-contact techniques, it would be that, hey, it can handle low end, it can handle the high end. It doesn't, is not affected by that. So anyway, that's the way that works. Good question. So here's one. Can you verify proper operation of an area velocity sensor without pulling the sensor? Good question there. There are a ton of area velocity sensors that are out there in the market, and they're typically mounted on a ring and they're installed in a pipe. So occasionally they will be covered or can be covered with debris and cause problems. With most technologies now, most of these will give you a reading. It would be either some sort of a signal strength reading or it can give you a reading of velocity signal. You can see if the depth is drifting and things like that. So there are different ways of verifying that without pulling the sensor, much better than in the old days. You can still stick it with a ruler above and get an idea of what's going on with your level, make sure that hasn't drifted. So a lot of people will go ahead and they'll do a level measurement, and then they may not adjust the level on site, but they will log what their reading was, and they will post-process that data. So they're trying to keep away from pulling sensors out of the pipe if they can possibly help it. Okay, are there web-based software packages available? And the answer to that is certainly. And there's a lot of that going on. Some people host their own data, as I indicated in the presentation. Some will use a cloud-based or web-based software, and there are more and more of those out there. Typically, they use a cellular package, which the cell phone will transmit the data to the web, and the user would be allowed to access the data, provide access to whoever they want to have access to the data. And that is the kind of the way of the future as well. The beauty of that is that the user doesn't necessarily have to own the software. The software is on the cloud, and they can access it without having to pay the money up front to get the servers and have IT involved and all that. So a lot of good stuff with web-based. More and more of it is going into data analysis, more analytics, and things like that. So yeah, so a lot of good stuff happening there as well. Okay, we use our modems, but we also want to connect to SCADA. Can we do that at the same time? The answer to that is yes, typically, depending on which equipment manufacturer you use, but I think all of us can do something similar to that. In the case, we've had situations where people will use the modem, the cell modem, to transmit data to a database, in our case, Flowlink Pro database, and it would be stored in that. But in addition to that, they want to go to their SCADA system, and you can normally run a Modbus output or a 4 to 20 analog output that would go, at the same time as the data host stuff or the cellular. So yeah, you can really split it off and make everybody happy. So that's a good deal. Let's see. What are safety measures or alert if working in an open manhole for gas emissions, etc.? I guess I am not the expert on the manhole safety part of this. I would say follow your local CDC guidelines and the normal measures. When I talk to a lot of the consultants out there, they're all doing pretty much the same stuff. They're following what is recommended by their local WEF group, and they are typically guided by the CDC. So, so I would say
Rick,
follow.
if I can, just to add to that, the obviously proper gas ventilation from the manhole is a requirement in most locations. So please follow those practices, as well as properly equipping any personnel going down to the confined space into the manhole with the appropriate gas monitoring equipment. But again, we don't provide expertise there, so we do encourage you to check with the local requirements.
Thank you, John. Another question here. Are there IS or intrinsic safe meters available, both contact or non-contact? And the answer to that is yeah, there's really a wide range of non-contact and contact intrinsic safe devices available. You need to kind of verify what you need. There are a limited number of Class 1 Division 1 meters, but there are, Class 1 Division 2. You have to kind of look at what your local requirements are if that's acceptable. So that's kind of how that works.
Zone 0 or Zone 1 or Division 1 and Division 2. Again, as Rick said, please check local requirements. Division 1 is basically that a hazardous or explosive atmosphere can exist under normal operating conditions, where Division 2 would be under some sort of unusual operating conditions, but please check for the local regulations for yourself.
Okay, here's another one. Explain the laser flow meter verification versus calibration. Good question. When these devices are calibrated, they go through a very extensive calibration procedure in manufacturing, as do everybody's. But in the field, that's always been a challenge. How do I know my meter is accurate? And people will typically do a level measurement, and they'll use some sort of a handheld velocity measurement. While the handheld velocity techniques are good and have been used forever, they are fairly, it's older techniques, older technology, I should say. And it's a difficult thing. There's a lot of human factor that goes in there. You have any one of us go in there and we take level readings, and we're all going to be maybe slightly different. We do velocity, handheld velocity profiling. We might be a little bit different there as well. So I am always careful on betting the bank, if you will, on the handheld velocity profiling technique. It's a good way to get to see if you are close. And what I normally recommend, if it's reading pretty close, I would go with what the meter says. Again, another thing that people do will log what they're reading or their profile or their manual measurement, level measurement, and then they can always go back and post-process that data. One of the biggest problems I've seen would be people will calibrate all the time. So they get calibration crazy. And every time they go to a site, they go, oh, I adjusted it by 1/4 of an inch. Now next 2 weeks, I adjusted it back by this. By the end of the study, you don't really know what you're working with. So your data can be all over the place. So calibration verification, you got to be a little careful with that. But there are ways and diagnostic tools that'll tell you if that meter is working correctly. So, so a lot of good stuff these days, technology-wise. And at this point, I do not see any more questions. John, are you getting any? Do you have anything to add?
No, I don't. Thank you.
Well, if that is all today, if you have any questions, comments, recommendations, anything, you can always reach me at rick.dey@teledyne, teledyne.com. And I'd be happy to answer those, and we'll do that as soon as you send them in. So once again, thank you very much for attending.
And I also thank you.